Here we are with 1.2 of the first chapter. So this is dealing with radicals now. We dealt with absolute value last time. Now we're looking at radical operations. Operations being just algebraically manipulating them. Okay, adding, subtracting, multiplying, dividing. How do we deal with the radicals? One thing that you might want to learn or relearn is how you deal with exponents. Okay, there are exponent laws that we need to be made aware of, and maybe I should make a video for those exponent laws just to remind you. But right now we're going to deal with these radical operations, okay? Now, first of all, we need to understand what a radical is. And this indeed here is what we call the radical, okay? This symbol right here. Now, I'll show you down here. That number outside is called the index. The number on the inside is called the radicand. And the symbol that we all know as square root is actually called the radical. Now, we can have a square root. Notice that if there's a square root, we don't write the 2. Okay, the 2 not written. It's just implied. Just like if I have x, for example, that's the same as saying 1x to the power of 1 over 1. These are all ones that we don't need. Okay, so a square root, we don't put the 2, but if we have a cube root, we have to put the cube in there. 4th root, 5th root, okay? This is how we name them. This is how we refer to them, the cube root. Okay, now there's a few things that we're going to deal with regards to roots. I'll show you a few different rules and tricks and sort of just tips to help you work through a lot of these questions. But before we deal with that, we have to understand and distinguish between even and odd indexes, okay? Because we know, for example, that I cannot take the square root of -4. You cannot do it. But I can take the square root of +4, right? I can take the square root of +4. Well, those are things that we know, but they also apply to higher indexes, okay? So let's look at a couple examples here. If in a given expression like this, n and a, n is your index and a is on the inside, okay? What would happen if a is positive and n is even? So let's choose the square root. We'll put it in and choose a positive number. Let's choose 9. Well, let's start like this. If x squared is equal to 9, how would you solve this? Well, we're going to be dealing with radicals and learning how to solve them. We need to solve for x, so how do you get rid of the squared? You do the opposite function, the inverse, right? Understand that the inverse is it just undoes it. So to undo addition, you subtract. To undo multiplication, you divide. To undo squaring, you square root. So you square root this side, you square root this side. And what we end up having is the possibility of 2 answers. We know that x could be either -3 or it could be +3, because -3 squared is positive and +3 squared is positive. Okay? Now we're going to have to come into talk about something else here. And this other thing is called the principal root. Okay? Now, if I actually asked you simply for the square root of 9, you're going to tell me that it's 3. It's only 3. Okay, the square root of 9 is 3. That is what they call a principal root. When you are solving an equation like this, if I say x squared is equal to 9, and you want to find out what would make this equation true, you need to do some algebraic stuff here, and through that process, you end up with the 2 possible solutions. So now, I'm going to say, okay, if I want to solve this, I have to take the square root of that side, and I have to take the square root of that side, which means x is equal to ±3. So there's a difference between solving using radicals, solving an equation using radicals, and just finding the square root of a number, okay? That distinction will come up again soon. Don't you worry about it. Now, if a is negative and n is even, so let's think about this. If I have a 9 in here, right? Oh wait, no, let's go -9 and n is even. Let's just use the square root because they're all the same. The square roots, the 4th roots, the 6th roots, the 8th roots, they all work exactly the same. And if you have a square root, can you take the square root of a negative number? And the answer to this is no. Okay, the answer to this is no. So you can't have any solutions. You can't have any solutions, right? So there are no solutions in this case. And here we have 2 possible solutions. Okay? Now, there is something here. You may learn that the square root of -1 actually does have a value. It is not, however, a real number. It's not part of our real number system because the square root of -1 doesn't really exist, but we give it a value of I. And that I stands for imaginary. Those are imaginary numbers. So if I have the square root of -9, okay, it's actually equal to 3I. You do not need to know that, but it is, anyways, a point of interest, hopefully, okay? Now, we dealt with even roots, okay? What about odd roots? If n is odd, so let's look at the cube root of a number. That would be beneficial to know what a perfect cube is. That's going to be the next step, okay? In the next chapter, we're going to deal with perfect squares and perfect cubes and perfect powers of 4. Just to bring it to your attention, a perfect square is a number that you can take the square root of, like 4 is 2, square root of 9 is 3, square root of 16 is 4, okay? A perfect cube would be the number that you can take the cube root of. So for example, the cube root of 8 is 2, and the cube root of 27 is 3, and the cube root of 64 is, well, let me put the 3 there, is 4, okay? So I'm going to use the cube root of 8, and you guys can tell me that that's 2, right? How about the cube root of -8? Can I put a negative number underneath an odd index? Well, if you think about what it means what number times itself 3 times in this case would give me a -8. And I'm hoping that you understand that if I multiply negative numbers together, so for example, -2 times -2 is +4. If I multiply by -2 again, it becomes -8, and then +16, and then -32, +64. So negatives work. Okay, you can take the cube root of a negative number. You can take the 5th root of a negative number. So if n is odd, then there is one solution. And it could be either positive or negative. Okay, so that's just sort of an introduction to the different indexes, the different indices, I guess would be the proper plural term. And I will show you a few tricks now, okay? These are kind of useful things. So we need to be comfortable going from radicals to exponents, okay? And one of the first things that we look at is this here, okay? So if I have the square root of x, that's the same as x to the 1/2. If I have the cube root of x, that's the same as saying x to the 1/3. Okay? Now what happens, say, if there is a number on your exponent, or an exponent on your radicand, right? So in that case, we're going to have, so for example, the cube root of x squared would be x to the power of 2/3. And you should be able to go back and forth, right? So if I had x to the power of 3/4, the 4 is the index, and that number on top. You see what I'm saying here? Okay, guys? Hopefully you can make some sense of that. I would like to bring something to your attention from grade 10 here, and that's this point right here. Okay? If you've got an index and an exponent, it actually doesn't matter which way you do it. And a perfect example of this is if I had the 4th root of 81 cubed. Okay? Some of you might be able to see that this is the same as saying 81 to the power of 3/4. And if you use your calculator and did 81 to the power of 0.75 or 3/4, since those are the same thing, you're going to get an answer. Okay? If you did this on your calculator, you'd get an answer. But there are ways of doing this without using your calculator. And I can't give you what 81 cubed is. But what I want you to see is that this can be written 2 ways. It can be written like this, or it could be written like this. And in this case, I do know that the 4th root of 81 is 3, which means that I can now do 3 cubed, which is 27. So I really, really, really want to stress the importance of understanding how these are the same, okay? And there's the example right here, that they're exactly the same, okay? What we also have to deal with, ladies and gentlemen, are exponents. Negative exponents. So remember, a negative exponent means that it becomes positive down below. So for example, x to the -2 is 1 over x squared. Well, if your exponent is a fraction, it's still the same thing, right? So x to the power of 2/3, -2/3, is equal to 1 over x to the power of positive 2/3. And then we just put it back into a radical. No big deal, okay? What's another one? So here's a bunch of things that we'll hopefully remember. Remember that if you have an nth root of a fraction, you can split it up, right? Remember that if you have a multiplication, for example, if you have the cube root of x times the cube root of y, that would be the cube root of xy. If you have the square root of x times the square root of y, that's the square root of xy. If you have the cube root of x times the square root of y, you actually can't do anything with that because it's a cube root and a square root, okay? You can't combine them, so they have to have the same index in order to combine them. There's a lot of things here that we deal with radicals. Now, I've seen a lot of you, wonder what we do with something like this. The square root of 4 times the square root of 2 would simply be the square root of 8. Can I add them together at all? You can't do anything with this. But what about if I had the square root of 3 plus the square root of 3? You don't combine them on the inside. You combine them on the outside because you have one of these root 3's and then another 1 root 3, which gives you 2 root 3's. Lots of different types of questions and problems that we can have with these radicals. Okay, let's look at a bunch of examples. I'm going to show you here the square root of x squared. Another thing that might be good to show you on here, sorry, I'll run back to here, is if I have the nth root of x to the n. If your index and your radical or your exponent are the same, it basically just cancels each other out and you call it x, right? So that would be, for example, the square root of x squared is simply x, right? You're looking for perfect squares. I'd like you to think about this concept that we did simplifying radicals before in grade 10. Remember, we looked at the square root of 50 and I asked you to simplify it. Well, what you need to do is you need to go, okay, what's a perfect square that goes into 50? 25 and times 2. That means we can break it up. This is one of the rules of radicals. You can separate them. And the square root of 25 is 5, root 2. This is what we call an entire radical. This is what we call a mixed radical. Okay, so this is how we can work through some of these. Let me see if you can figure out how to simplify some of these. So what we're looking at is taking out perfect squares. We did it with numbers. You can find a perfect square as 25. But can you do it with variables? Well, I'm hoping that you can see that this is the same as the square root of, well, let's take a perfect square out of this, x squared times x. Well, you know that that's going to be the square root of x squared times the square root of x, so it's just x root x, right? Now, if I have x to the power of 4, well, there's a couple ways that you could look at this. You could look at it like this. If you converted it to exponents, it'd be x to the power of 4 over 2, which is just x squared. That's it. You could look at it another way. Take it into perfect squares. X squared times x squared. When you multiply with the same base, you add the exponents. Well, that's the same as writing this, which is just x times x, which is x squared. You'll notice, hopefully, a pattern between the power on the radicand and the index. Let's try x to the power of 5. That is a 5 here, right? If we broke it into perfect squares, x squared, and I've got one more x. Well, the square root of x squared is x, another x, and then a root x, or x squared root x, okay? Hopefully you can take a second look at this one, see if you can make some sense out of it, right? And you'll see that you could break it into x squared times x squared times x squared, hopefully. Boom, boom, which gives you x times x times x, which is x cubed. All right. Now, here are a bunch of questions that I'm going to ask you to try, and I will go over them one by one. So let's start up here. You can think about it as the square root of 16 times the square root of x squared. Both of those are perfect squares, so it simply becomes 4x. try to think of them separately. As an entire radicand, it can be a little confusing, but let's deal with the numbers and then the variables separately. Square root of 9 is 3. And if you look at the cubed up here, right, if you looked at the cubed up there, wherever it was, you'll see that it breaks down to x squared and x, right? So the x squared can come out. So let me just look at something. Let's put perfect squares there. X and then x squared and then x. The square root of 9 is 3. The square root of x squared is x. And I have a root x left. And there's your answer. Okay? What about this one? Can you take the square root of 6? No, you can't. Can you take the square root of x squared? X to the power of 6. Yes, it's x squared, x squared, x squared. Y is y squared, y squared, y. Let's look at all the perfect squares. 1, 2, 3 x's means x cubed on the outside. 1, 2 y's means y squared on the outside. What's left on the inside? The 6 and the y. Boom, you're done. Okay, and it's the same thing, ladies and gentlemen, over and over and over. Let's try the next ones. The cube root of 64. Well, it'd be a good idea to have a list of cubes. If you don't know how to use it on your calculator, maybe you could try and figure out how to find the cube root on your calculator. I'll show you if you need it. Every calculator is a little bit different, but it just so happens that the cube root of 64 is 4. Well, what's the cube root of negative 64? Since it's an index, it can be a negative. It's a negative 4. There you go. Now, let's throw some variables in there. Cube roots. So what we're looking at is taking out perfect cubes. 2 is not a perfect cube, so that has to stay in there. Okay, so the 2. But the x to the power of 5, a perfect cube is x to the power of 3, and leaves me with an x squared. And then I have y cubed. That's a perfect cube, so let's take it out. Boom, boom. Those can come out, so it becomes xy. And then I have the cube root of, what else is left? 2x squared. And you are done with that. Okay? Okay. Let's look at a couple more. A couple more examples. Mo. 4th root of 16. Well, 2 times 2 times 2 times 2. So I know the answer to that is 2. Now, can you take the 4th root of a negative 16? Well, you know what? Call it 2i if you want. But we're going to say because it's an even root, you can't take the even root of a negative number. So, no working. All right? Let's use variables now. So, 4th root of, let's make perfect powers of 4, which would be x to the power of 4. And then we break it down to x to the power, well, whatever's left is x to the power of 3, right? And then we have y to the power of 4 times y. Perfect power of 4, perfect power of 4, xy. What's left on the inside? X cubed and y. Okay, I think we got one more row here, and then I'll leave you alone for now. This one becomes a little bit weird. If you want to do it in a couple different ways, you can think about it a couple different ways. It's a little tricky. How the hell do we deal with these? Well, you know that there's a 2 in here. You could convert it into exponents if you want. So the inside would be x to the power of 1/2, all to the power of 1/3, right? All to the power of 1/3. So I'll explain to you how we can find these answers. So when you power to a power, your law is that you multiply exponents. So it's x to the power of 1/6, which is the 6th root of x. Now tell me how we could have got a 6th index here, right? And if you think about it, you just multiply the indices together, and it gives you 6, all right? In this case too, cube root and then 6th root. Okay, well that means that it's going to be the 6th root of x squared y. That's it, done. Okay? Sometimes, you know, with these questions, they're going to say, oh, it can only be a positive or a negative number. Your answers in the back of the book will say, oh, it has to be an absolute value of a number. So, for example, if I was going to ask you for the square root of x, you know the answer to this, well, x has to be greater than or equal to 0, which basically means the absolute value of x. That's all we're talking about. Okay? We're going to start looking at what we call restrictions. What values of x work, what values of x don't work. We'll get to that a little bit later. That's long enough now. If you have any questions, folks, do not forget to ask.